Hello all, welcome to the session on join operation in relational algebra. Types of join operation. In the previous video we have already discussed about the join operation and the cross join operation. Here are some of the additional types of join operation, that is equi join, natural join, theta join and outer join. There are three types of outer join, that is full outer join, left outer join and right outer join. Yes, let us understand about equi join operation. The join operation where the only comparison operator used is equal to symbol in join condition is called equi join. Yes, let us consider the two relation, that is faculty relation and course relation. The faculty relation consists of four attributes, that is faculty ID, name of the faculty, the department and the designation. In the course relation, we have got course ID, title and the faculty ID. Now if I want to join these two relation, as per the guidelines, the join condition, in the join condition one attribute should be the primary key. In the faculty ID, in faculty relation, faculty ID is a primary key. In the course relation, course ID is a primary key. Now if I want to join the two relation, that is faculty and course, in the join the join condition should be nothing but it consists of the faculty ID and FID of the relation course. Let us look into the relational algebra. Yes, you can see here we have two relation, faculty and course, and this is an example for an equi join because in the comparison operator we have used equal to symbol, okay, in join condition. And we have is the join condition has two attributes, that is faculty ID, that is a primary key of a faculty relation, and we have FID, that is faculty ID of relation, foreign key of the relation course. And finally the resultant relation looks like this. You can see here the faculty, after joining the faculty and course using equi join operation, the final resultant relation looks like this, where it consists of two rows. You can see that the 1001 will be matched with 1001 and 1003 will be matched with the 1003 tuples. So only the resultant relation consists of two rows. And also you can see here there are totally 7 columns, 7 attributes available in the resultant relation. And if you notice the first attribute and the last attribute, you can see both are same. So this second attribute is redundant. So this is called as a superfluous attribute. So this redundant attribute is called as superfluous attribute. So we can get rid of this superfluous attribute by making use of a natural join operation. So this is one of the disadvantages of equi join, where it can consist of a superfluous attribute, that is a redundant attribute. Yes, this could be you can get rid of this superfluous attribute by making use of a natural join operation. Let us understand what is natural join. The natural join can be used if there is a common attribute between the relation. Yes, if I want to join a two relation, any one of the attributes should be common. When I say common, even the name and the type of the attribute must be same in both the relations. Natural join does not use any comparison operator. No, it doesn't use any comparison operator. The notation used for the natural join is asterisk. Okay, the notation used for the join operation is asterisk. Yes, natural join is denoted by asterisk, was created to get rid of the second superfluous attribute in an equi join condition. Yes, natural join is used to get rid of the superfluous attribute. Well, let us consider these two relation. We have customer and order relation. And in customer, we have customer ID, customer name and age. In order relation, we have got customer ID, order name and cost. Yes, the guidelines for the natural join is any of there should be a common attribute between the relations. You can see here we have the common attribute CID and CID. Even the name and the type of this attribute are same. So let me check my resultant relation. Yes, after performing this natural join, just look at the notation of the natural join. It's asterisk. Okay, and the resultant relation looks like this, and in this we don't have any superfluous attribute, that is we don't have any second attribute of CID. Yes, that's about the natural join, where it get rid of the superfluous attribute, and we don't specify any join condition here. And there is no comparison operator used in the notation of natural join. Yes, let us understand about the theta join. The join operation with comparison operator like equal to, lesser than symbol, less than equal to, greater than equal to, and not equal to symbol in the join condition is called a theta join. In my join condition, if I have the symbol, it is called as a theta join. I can say even a equi join is also called as a theta join because it consists of a equal to operator. Yeah, let us consider the two relation, that is customer and order. And yes, you can see this, we have, after joining the customer and order, and the join condition consists of greater than symbol. You can see the join condition consists of a greater than symbol, that is customer ID greater than the order ID. So the resultant relation looks like this, where it consists of CID and OID also. Okay, here CID will be always greater than the order ID. Customer ID is always greater than the order ID. So that was the condition. So that's about the theta join. Yes, let us consider a simple example. We have got a problem statement, that is list the names of manager who have at least one dependent. Yeah, I repeat once again, list the names of the managers who have at least one dependent. Here we have got three relation: employee, department, and dependent. Now the question is, list the names. Where will I get the information about the names? Yes, I will get it through in a employee table. In an employee table, I have first name, middle initial, and the last name. I will get those information about the names of the employees will be available in an employee table. Now list the names of managers. Where will I get in which table, in which relation will I get the information about the manager? We don't get the information of the managers in employee table. We get the information about the managers in a department table. So I require even department and employee. Employee for the list of the names, for the department for the information about the managers. And list the names of manager who have at least one dependent. Yes, here we have got all the dependents information. Now let me tell me a scenario where there might be some managers without any dependents. So what I have to do is, first I will retrieve the column manager SSN from department table. After that I will retrieve the column ESSN from the dependent table. To retrieve the column in relational algebra we use pi notation. Okay, but to retrieve the row we use sigma notation. Yes, first what I will be doing here is we will be just retrieve the column manager SSN from the department relation. Yes, you can see here from the department relation I will be retrieving the manager SSN using pi. Just one column that is manager SSN is retrieved and stored. This is an intermediate relation name, that is nothing but managers within the bracket SSN. So this manager underscore SSN attribute is renamed as SSN. Okay, this I will tell you why we have renamed, because to perform a natural join at the later part, that's why we have just renamed it to SSN. Next what I will be doing is I will be retrieving ESSN from dependent relation. Yes, yeah, you can see here from the dependent relation I will be I want only the column ESSN column using a pi operation, and the intermediate relation looks like this: the employees with dependents and this ESSN is renamed as SSN. Okay, now this manager SSN consists of the social security number of managers, and employees with dependent consist of the all the employees who has dependents. Now what I'm going to do here is I will perform a intersect operation with manager SSN and employees with dependents, so that I can get those information of managers who has dependents, because there might be some managers without dependents. So if the manager doesn't have dependent, their details will not be available here. So so in order to get the managers as per the questions, you can see the list the names of managers who have at least one dependent. So their ESSN will be available in this dependent relation. So I can perform manager SSN intersect ESSN, so which is common, which means I can say I just retrieve those information about the managers. You can see like this: manager intersect employees with dependents. So the resultant relation is nothing but the managers with dependents. Yeah, that is clear. Yes, I have got the information of the managers with dependents. Now what they have asked in the question is list the names of the manager. No, now this resultant relation has to be performed joined with employee. So what I will be doing is will be performing a natural join, because I can see that we have already renamed it as SSN, and in employee we have a common attribute SSN. Now I will perform a natural join it with the employee. Look at here, managers with dependents, natural join with employee. I repeat again, why natural join? For the condition for the natural join here is any one of the attributes should be same, should be common. Like in employee we have SSN, and in managers with dependents we have also have a relation called as, an attribute called as SSN. So that's why we have renamed it. This manager underscore SSN is renamed as SSN, and ESSN is renamed as SSN. And I perform intersection operation, and we got those information managers with dependents, and this managers with dependent is combined with employee to get their names. As you can see in the question they have asked list the names. Yes, I will be getting, because after combining manager SSN with employee I will get I don't need these the department number or birth date and address. I just need the first name and the last name. So that's why with the help of a pi operation I just retrieve the last name and the first name. I'm just retrieving the column, that's it, and this is my final result. Yes, that's about this query. Let us look into the next. As let us understand about outer join operation. There are three types of outer join operation, that is left outer join, right outer join, and full outer join. Yes, let us begin with left outer join operation. So this is a notation, that is join operation facing towards left. Yes, let us understand about the definition about left outer join. It returns all the values from the left table and also the matched values from the right table. Let us see the syntax of left outer join. So that is R left outer join operation, then yes. So where R and S are the relation. So this is a notation for the left outer join operation. Let us understand with a simple example. Let me consider this two relation, that is employee and department relation. In employee relation we have got three attributes: name, employee ID, and department name. In department relation we have got two attributes, that is department name and manager. Now if we perform employee left join outer join operation with department, all the tuples of the resultant relation will consist of all the tuples of employee plus the matching tuples of department. Yes, this is our resultant relation. As the definition, you can see that all the tuples of employee returns. You can see here the left outer join, all the tuples of left outer join is available here, and only the matching tuples of the department relations is available here. So the tuple that doesn't match will be null value. Okay, let me consider the first tuple. of the department name. So the join condition will be matching with the department name. That is the only attribute which is common in both the relation. Yes, for the finance department, there is no match, so the resultant manager will be null. And we have got sales department. Yes, for the sales department, we have a match, and the corresponding manager of the sales department is Harriet. Finance department, there is no match for the finance department. That's why the manager is null. Yes, for the fourth row, we have a match for the sales department, and the manager is Harriet. And department execute, there is no match for executive department, and the corresponding manager is null. So this is a resultant relation where all the tuples of left relation exist, and only the matching tuples of the right relation is added over here. Okay, this is about the left outer join operation. Now next we look into the right outer join operation. Look at the notation for the right outer join. That is the join operation facing towards the right. Yes, let us look into the definition. A right outer join operation returns all the values from the right table and also matched values from the left table. Let me look at the syntax. You can see the notation here. R right outer join operation, then yes, where R and S are the relations. Let me consider the same relations, that is employee and department. Now we are performing employee right outer join operation with department relation. So all the tuples of department relations will exist in the resultant relation, plus the matching tuples of the left table will be added to the resultant relation. Yes, you can see here both the sales and the production is available here. All the tuples of department relation is available here, and only matching tuples with the employee relation. You can see sales, for the sales department there is a match, that is the second row of employee tuple. You can see that Sally 2241 and the manager is Harriet, and there is one more match for the sales department, that is again Harriet. And for the production, there is no match for the production department, so the corresponding employee and employee name and the employee ID is null here. So this is about the right outer join operation, where all the values of the right table exist. In addition to that, the matching tuples of the left table will be added in the resultant relation. So this is about the right join operation. Next we'll look into the full outer join operations. Yes, let us look into the notation of this full outer join operation, where join operation facing towards left and right. Yes, let us understand about the definitions of full outer join. Full outer join returns a set that includes rows from both left and right tables. So the full outer join will include the tuples from both left and right table. Whenever there is no matching row exist for the row in the left table, the columns of the right table will have null values, and vice versa. Yes, this is a syntax of full outer join, where the join operation is pointing towards both the directions, that left and yes. And yes, we'll consider the same relation, that is employee and department. And in full outer join operation, all the tuples from the left table and all the tuples from the right table exist in the resultant relation. Now, well, if there is no match, now for example, for finance there is no match for the finance, in that case manager will be null. And when I consider this production department, there will be no match for the production department, hence the name and employee ID will be null. Yes, look at this. So in this full outer join operation, it is a combination of all the tuples of left and the right table, and whenever if there is no match, the corresponding table will be values will be null. You can see here the finance, there is no match for the finance, the corresponding manager is null. At the same time, there is no match for the production here, the corresponding name and employee ID will be null. So this is about the full outer join operation. Yes, that's it about the join operations. Thank you for watching this video. Please do like, subscribe and share.